All right, my friends. So this one, it looks similar to a problem we had seen before. It talks about that the snow, but the last one we were doing, I think it was for December 21st, and this one's now March 21st, which should be probably last day of winter, first day of spring. And so I don't really have a grid on this, so I'm just gonna try and see if I can figure this out. So down here, we're gonna call this time in days, and then I'm gonna put after March 21st. And this is snow in inches. All right, so you have to figure out how we're going to count. Looks like we're going up to 50 days, so maybe count down here by fives. That probably would work for you all. $45, $50, maybe $55. Take it out, okay? And then snowpack it goes up to 156 inches. So maybe let's count this in tens. Oh, running out of room. 30, 140, 150. All right, let's see. Very first day, we're like way up here. 10 days later, we are at 140. 20 days, we're at 120. 30 days, we're at 110. 40 days, we're at 95. 50 days, we're at 75. Okay, so snow's melting, agree? So hopefully you have some sort of line. Hi. Well, thank you very much. Mike. All right, so that's basically all I'd be looking at if you were graphing it. You know, I'm looking at, do you have it labeled down here, right? You know, did you label over here? How are your labels as far as your graph goes? Do you have points that are drawn? Do you have a line of best fit that you try to squeeze in there? Those are all different things I'd be looking at to give you points if it was on a quiz, okay? Let's see. Independent variable. I can go back on this. Independent variable are the x values, dependent are the y. Okay, plot the graph, got it. Now we have to select 2 points. I don't know, I'll pick the third point and maybe the last point. Okay, and I just arbitrarily picking them. I'm not putting any rhyme or reason. I'm making sure they're just not right next to each other. So the third and the last. So the third point is 20, 120. The last is 50, 75. So label them x1, y1, x2, y2. Find the slope. So you get 75 minus 120 over 50 minus 20. What's 75? Oops. That should be 120. Let's see. 85, 95, 105, 115. So this looks like negative 45 over 30. Somebody have a calculator? If so, will you go 45 divided by 30 for me, please?
9/6.
9/6. And then what's 9/6 as a
29. 3/2.
3 over 2. So 1.5. Okay, and again, I think sometimes it's easier to define what the slope means if you put it as a decimal. It's not always, but as far as these go, I mean, I know I can put that over 1. So let's find our line of best fit equation. So we're going to use this first. Being I already used x1, y1 times x minus 20. Distribute. Plus, what's 1.5 times 20? 30? Is it 30? I think it is. I'm going to add 120 to both sides. So y equals negative 1.5x plus 150. So by me picking those 2 points, this is what I found out my line of best fit. Is my correlation negative or positive? It's negative. The reason it's negative is my slope is negative. That's the only reason that it's negative correlation. Negative correlation doesn't mean it's bad. It just means the slope of the line of the best fit would be negative. Okay? Let's get apply. What is the slope? We have that. What does the slope mean in the context of this problem? Well, being that we switch this to this, I know that this is the y-axis, and the y-axis we said was snow in inches. And this is days. So what does this mean in the context of the problem? We lose, on average, 1.5 inches of snow each day. Okay? And then what are the coordinates of the y-intercept? So the y-intercept, we have 0, 150. Okay. Hey, friends. What does this mean in the context? What our model shows, we have 150-inch base on first day of spring. Which is March 21st. Okay, now, being that we picked 2 points and we found a line of best fit, if you look at our data has 0, 156. Okay, but we show the y-intercepts this. So notice they're slightly different. Sometimes when you create your line of best fit, it doesn't always match up entirely. Okay? And that's okay. You know, it should be pretty close, but notice that our data showed 0, 156, but our line of best fit that we created showed 0, 150. So our data was our line of best fit was an underestimate what our data showed. Okay, and that's okay. It's the reality of it. All right, what else do we have? I'm gonna write that equation down. Y equals negative 1.5x plus 150. So we know that this is the day. This is snow in inches. All right, so how much snow would we have after 70 days? Well, I'm going to plug the 70 into our equation. Somebody with a calculator, what's 15 times 70? Anybody? 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 Anybody?
15 times 70?
Yeah.
1,050.
Okay, oh, it should have been 1.5, so it'll be 1,050, you said? Should be 150 because I forgot to tell you the decimal. Sorry about that. So basically, after 70 days, we should have 6 inches of snow left. Okay, so it's a melting. Here comes summer. And then when would we have 0 inches of snow? So I'm going to take the 0, plug it into the y. Let's see, 150. Let's move the 150 over by subtracting it. Divide each side by negative 1.5. Looks like, what is 1,500 over 15? Okay, let's see. Is it 100? Is that what you get? So after 100 days, we're not going to have any snow up there. We're well into summer. Okay, so we've been doing these quite a bit. Agree? So there are times that our line of best fit is a prediction. Line of best fit, LOBF. Predict. Oh, man. If I could spell. Prediction. Okay? So, years ago, people used to always joke that the weather people were wrong. Well, they're trying to make a prediction based on something that hadn't happened yet. So they're looking at different linear models or different quadratic models or different some sort of model to see these are the parameters we have in place, therefore this is what should happen. And again, the news shouldn't say, yeah, it's going to be, 58 degrees tomorrow. The weather person probably should say the weather should be 58 degrees based on our models that we're looking at. But they don't. And then everyone gets to give them grief. They get.
It's usually pretty right though. Like if it's like 50 today and then it's like, oh, it's gonna be 30 tomorrow. It's gonna be cold.
Yeah. Oh yeah. The best though is they were predicting. Y'all might remember this. You were probably in middle school, maybe elementary school. They had predicted this huge snowstorm coming in. So they called a snow day the night before. And the next day it was sunny. Yeah, it wasn't that long ago. That was like the best.
One day, like in 7th grade, where it's like they said it wasn't going to snow at all that day, but then took the bus like an hour to get to school.
Huh.
So
it happens. There are definitely some characteristics out there. Okay, so how is everybody? All right, I am on page 183. I think I can pull these notes up. Let's see. Yeah. What? Oh, I thought you said my name. It happens. We're going to go through these notes pretty quickly. I'm not going to worry about testing it, but this will be when we're kind of playing around today and tomorrow with Desmos that I'd asked you to load on your phones. But let's see, smartboard files, regular functions, number 9. Okay. So these instructions, sometimes they're going to be presented to you on the graphing calculator, but a lot of times we can work with Desmos and accomplish the same exact thing. And the benefit with Desmos is y'all have a phone for the most part, which you can go to the App Store and you can load Desmos for free. Now, the problem with Desmos, though it's an incredible thing, they're not going to let you use your phone on a test or a quiz, including ACT or SAT. But I have heard that ACT and SAT both have joined with Desmos. So when they start offering the test on the computer, you would have a link that would take you to Desmos on the computer, which is pretty cool. So, so this is talking about some neighborhood pool, and I don't. There are these. You don't have to worry about necessarily taking these notes. Okay, these are all available for you. Here's the problem. If I showed you this on the graphing calculator, I have 8 graphing calculators, and there might be one of you on here that has the regular graphing calculator. Okay, so this is all directions if I was using the graphing calculator, which is fine. It's just it's not always helpful for us if we don't have the technology readily available for everyone else. So the R value, so this perfect correlation would have an R value that's close to +1. This, a strong positive, you would have a positive probably 0.85 correlation. This is a weak one, so this would be probably a positive 0.5. No correlation is very close to 0. And then we got negative weak, so we'd have negative 0.5, negative 0.85 roughly. And again, I'm guesstimating on these, and negative 1. So what the correlation means, if it's positive, slope is positive. If it's negative, slope is negative. If it's 0, you're not comparing. Okay, you could try and compare 2 things. You could say the number of coins I have in my pocket versus my age. Okay? Well, someone might have a coin in their pockets because they found a quarter out in the hallway. That doesn't mean that your age is indicative on you having coins in your pocket. So there's definitely 2 things that you could try and compare. Whether they have a correlation or not, we don't know until we actually put the data. All right, so not really going to talk about residuals too much. All right, so if you have your phone, go onto it. If you've loaded Desmos, open up Desmos. If you haven't loaded Desmos, I highly encourage you to put Desmos. Go to your App Store and get into Desmos. But I'm going to play around with Desmos here. And it's going to work very much the same way. And I'm going to kind of walk through how Desmos works. So right now, as Desmos sits on your phone, if your phone was open, you're going to have the graph, I believe, on the top, and then you'd have that blue region or some green region or something like that below. Is that correct? When you do it on the computer has a larger screen, so it's able to do it on the left side of your graph versus underneath it. So there's things that you have to know that your computer's going to do. So if you hit the plus button and then you go to table, we wanted to see based on this. So it looks like I'm looking on page 83. I'm just going to use that data. It's statistics student wondered if they could predict the number of people that would be at the neighborhood pool based on if it was a warm day outside, and they track the attendance over several days. So I'm going to just plug in the X values, 83, 84, 85, 86. Yeah, you can. 86, 87, 88, 89, 89, 91, 92, 93, 94, 95, 96. All right. And it's really, the nice thing is Desmos is pretty nice to work with on the computer because it's pretty user friendly as long as you realize the ideas that are coming with it. And don't panic if things aren't showing up on your graph yet. Notice my graph is only at -10 to +8, 127, 124. So we have to find it. And the great thing about Desmos versus the graphing calculator is in order to do your window, you can just drag it around to find it. 39, 145, 142, 138, and 145. All right, so if you wanted to find your data, and I'm going to change my projection to a little darker mode. I'm going to zoom out a little bit. Oh, there's my data right up there. If you center it on your screen, you kind of zoom in on it a little bit. So the X value is the temperature outside. The Y value is the number of people at our school. And you could, if you click on your points, these points, if you just click on them, basically are our data points that we're graphing. Okay? Now on Desmos, notice it says X1 and Y1 up at the top left. So if we want Desmos to find out line of best fit, we go down to our next area and we say Y1, just type Y1, and then you use tilde, which is the shift above tab on my computer. On your phone, it's probably under the alpha menu. MX1 plus B. So there's some stuff up here that it talks about. So M is your slope. So 1.55 is your slope. B is -3.95. So sometimes there's information that you do on the calculator, or you do on your phone, or you do on your computer, especially when you're doing lines of best fit. Sometimes things don't make complete sense. But there's something that's down where it says statistics, and there's an R² value. You don't worry about R² when you're dealing with straight lines. You just worry about R. R is a one-dimensional distance. So what the R value, how it computes is this. If you have a distance above your line, it's positive, a vertical distance. If you have a distance below the line, it's negative. So basically your R value is doing a couple things. R should be positive because our slope is positive. We have an R value that is 0.9456. So think of that as like you're getting a 94.6% on a test. That's pretty good. So our data follows a pretty good pattern. Seems to show there's a correlation here. Okay? So our R value is pretty good. It says, what is the equation of the line of best fit? My equation is Y equals 1.55x minus 395. Okay? So 1.55. (1.55x) minus, I already forgot, minus 395. Okay, so this, come on. This is my slope. Come on. Yeah. My computer is being goofy. There we go. Here's my slope. So my slope is 1.55. We put it over 1. Remember, we said the x value was temperature, and this is number of people. So this is the y value over the x value. So the slope, I don't know why I have value about value. So the slope means we get, on average, 1.55 more people each degree warmer. Okay? So that's basically what that means in the context. But the goofy one is this. This is my y-intercept. So 0, negative 3.95. So your x value is degrees, and then you have people. So what this means in the context of this problem, which is going to be nonsense, is when 0 degrees outside, we have negative 3.95 people. Okay? This is an extrapolation. An extrapolation should not be trusted. Okay? But the nice thing is, I feel this Desmos is a pretty positive, pretty powerful tool that allows you to see an awful lot of information about lines of best fit. Okay? So down here is our y-axis. Okay? So does it make sense if it's 0 degrees outside, we have negative people at the pool? No. But because our data is way up here, that means we're doing an extrapolation. An extrapolation should not be trusted in statistics. Unfortunately, an extrapolation often is what you could do. Okay? So I have a worksheet. We're going to do one side of it. And you have the rest of the period to work on it. So I'll hand these out. I was hoping you were using Desmos nonstop, but I've never seen people's fingers go so quickly on Desmos. Pretty disrespectful to be on your phone nonstop in my class. Let's shake it out of our systems. Guys, when we come back after break, my thing up there was for cell phones. It's going to be for cell phones again. If you don't like the policy, go talk to your counselor and withdraw from my class. Yeah, so it's just the front page. So all we're going to do is look at screen time versus GPA. That's all you have to work on. If you need help on this, you can ask me. But you only have to do the front. Okay? What's that?
How can I tell which one's X and Y?
Oh, it's usually the first one listed. Screen time will be X. GPA will be Y. Did I give everyone one? Did I give Key one? Yeah. Okay, I got one. Oh, I didn't give a front. I'm sorry, fellas. Didn't mean to forget about you. Were you with that line best fit to work? I did mine. Did you? When you?
No.
The big thing on it.
It's like confusing with that one.
Yeah. So the alpha thing's kind of weird. So you just type like Y1 once you on your alpha stuff. You don't have to do a subscript, but then it's finding the tilde, because if you do Y equals, it doesn't recognize it. So the tilde and Desmos is saying, hey, how do we make the line best fit work? So if you want to do this on your device and you need help finding stuff, I could perhaps help you on your phones.